Welcome back, Calculus. We're going to look at the last part of related rates. I'm calling this related rates part four, where we look at angles of uh, uh, the rate of change of how angles move in triangles. So, uh, angular related rate problems. So there will be some trig involved. Before I give you some general tips, um, if I give you a right triangle with some angle, um, I just want to remember what the six trig functions that we use are, because it's going to help with what we're doing. And you've written this down a bunch of times, which is fine. Um, but it'll be good to refer back to, and at least it's right here. So we have cosecant, secant, and cotangent. So from this angle's perspective, we have the opposite leg, the adjacent leg, and the hypotenuse. So sine is going to be opposite over hypotenuse. Cosine is adjacent over hypotenuse. And the tangent is opposite over adjacent. Cosecant, we're just going to flip sine, so it's going to be hypotenuse over opposite. Secant of an angle is the ratio of the hypotenuse to the adjacent leg, and the cotangent of an angle is the ratio of the adjacent leg to the opposite leg. Okay, so in all of these problems we've been doing, the idea is we're looking for a rate of change, we're given information. Based on that, come up with a relationship, take our derivative, plug in the given information, and answer the question. So some general tips here. We're going to pick your trig function. The trig functions are what's going to relate the side legs of a triangle and the angle that's changing. So you're going to pick a trig function, and you're going to want it to include the rate we want to know. And the other piece of the triangle that we want is going to be the constant. This will make sense when we do an example. But pick a trig function that deals with the rate that we know and the constant. And when you pick your trig function, you'll have two options. Right? If I want something that relates hypotenuse and adjacent, I could either use cosine or cosecant, because both of them relate hypotenuse to adjacent. So you're going to have two options once you pick a trig function that relates to two sides that you want. So when we do this, we're going to pick your trig function so that the constant is in the denominator. And the reason why is because it just makes the algebra / calculus a little bit easier. So it just makes the work easier. Not that we need it, but it's just helpful to have. All right, so given the triangle below, if the length of side A is increasing at a rate of 2 units per second, what is the rate of change of the angle theta when A is 3 and B is 4? The side length of B is constant, and we want exact answers. By the way, another good tip, I should probably put this down. Have your calculator in radians. Unless otherwise stated, keep in radians. All right, so in this problem, we're trying to find out this side length A is getting bigger. And as it's getting bigger, this angle is growing. It's getting bigger and bigger and bigger as A gets bigger. And we want to know the rate of change of that angle. So when the rate of change of side A is 2, so I'm going to call that A prime is 2. We want to know what's the rate of change of angle theta. So I'm looking for the rate of change of angle theta. So we're looking for A prime, theta prime. And we want this at the moment that the side length A is 3 and the side length B is 4. So it's telling us that the length B is constant. So as A gets bigger, C is going to get a little bit bigger too, but as A gets bigger, B doesn't change. So B is staying a constant. It's going to stay that constant length. So B is going to be my constant. And the rate that I know is, I know the rate of A. So A is the opposite leg of angle theta, and B is the adjacent leg. So now I need to pick a trig function that relates opposite and adjacent. So we have tangent and we have cotangent. Now I want whichever one puts my constant in the bottom. So I want adjacent to be on the bottom. So tangent's going to be the function that has adjacent in the bottom. So this is my equation. This is my trig function that relates the information I have and the information I want. The tangent of angle theta is the opposite leg, which is A, over the adjacent leg, which is B. Now we know B is 4, and that's a constant. So I can put this as A over 4 because 4 isn't going to change. The A is going to change because the side length of A is getting bigger. Okay. Now we do what we've always been doing: take the derivative of both sides, and the derivative of tangent is secant squared theta, and then times theta prime. The derivative of A over 4, and this might help. You can think of this as like 1/4 A. So that derivative of that is just going to be 1/4 A prime. So this is what I want to know. So I need to figure out what everything else is by plugging in and solving. Secant squared of theta. So if you remember, we can do this on the side here. Secant theta is the ratio of hypotenuse to adjacent. So the adjacent leg we know is 4. But I don't know what C is, the hypotenuse. And we can figure that out. We can just Pythagorean theorem here. When A is 3 and B is 4, we get 3 squared plus 4 squared equals C squared. So 9 plus 16 equals C squared. 9 plus 16 is 25. So if C squared is 25, then C has to be 5. So secant theta is just a hypotenuse over adjacent, which is 5 over 4. So secant squared is going to be 5 over 4 squared. And A prime, we already know, is 2. It's from right here. All right, now it's just some algebra 1. 5 over 4 squared is 25 over 16. Four times 2 is 2/4, which is the same thing as 1/2. So now I'll just multiply both sides by 16 and divide both sides by 25. So 2 divided by 16 is 8, so I'm going to have 8/25. And it's not degrees per second. We're talking about an angle, but we're in radians per second. So what's going on is as A is getting bigger, this angle, so as A gets bigger, this triangle is getting bigger and bigger and bigger. And the angle right here is changing at a rate of 8 and 8.2, 8 and 8 over 25 radians per second. So there we go. Okay. All right, so that's how all these problems are going to work out. And we'll do a couple more together so that in class we can just spend time working on these. This example here, we have a rocket taken off from a launch pad on the ground. A camera that is 2,000 feet away from the launch pad tracks the rocket as it goes up. What is the rate of the angle of elevation of the camera changing when the rocket is at an elevation of 3,000 feet, moving upward at a rate of 12,000 feet per second. So we're going to approximate the answer, which is fine. But something like this, like certainly draw it, because right as I read it, it's kind of, you might be saying like what's going on here, which is fine. So let's see if I can draw something. All right, so we have a rocket going up. So here's the ground. And you have this rocket going up. Okay, and we have a camera right here. My camera. And the angle. So as your ship goes into the air, this angle, the camera, in order for it to follow the rocket, is going to increase. So that's my angle getting bigger and bigger and bigger. So rocket takes off from a launch pad. Ooh. 1 second. All right, so the rocket takes off from a launch pad on the ground. The camera is 2,000 feet away. So this is 2,000 feet away from the launch pad. So this is the launch pad. At what rate is the angle of elevation changing of the camera when the rocket is at an elevation? So at some moment in time, this elevation becomes 3,000 feet. So that's increasing. So that's not constant. What is constant is this 2,000. And we know that when it's at an elevation of 3,000 feet, it's moving upwards at a rate of 12,000 feet per second. So I'm going to call this X and Y. So we know that Y is the speed of that it's going up, which is 1,200 feet per second. We're trying to find the rate of change of the angle. So the rate that I know is Y, the constant is X. So this is opposite and this is adjacent. The function that's going to relate opposite and adjacent to each other is either tangent or cotangent. I want the adjacent to be on the bottom, so I'm going to use tangent because tangent is the ratio of opposite to adjacent. So opposite is Y, the adjacent is a constant, so I'm going to, instead of putting X, I'm going to put 2,000. Y is a variable that's changing, so I'm not going to use a number, I'm going to use the letter. So same thing here. Let's take the derivative of both sides. The derivative of tangent theta is secant squared theta times theta prime. The derivative of y over 2,000 is y prime over 2,000. I think on the, I don't want to, I'll be consistent here. This is the same thing as 1 over 2,000 times y. So the derivative of that would be, don't do that. So the derivative of this would just be 1 over 2,000 y prime. All right, so then we got to find out what secant theta is. We know what y prime is, and then we can solve for theta. So secant theta, let's do a different color here. Is hypotenuse over adjacent, just like we did over there. Yep. The adjacent leg is 2,000. And hypotenuse, we just need the Pythagorean theorem. So I'm just going to call this C, and C is going to be, you do a squared plus b squared, and then you take the square root. So it's going to be the square root of a squared, or x squared plus y squared. So we're doing approximate answers here, and I think we get about 3,605 points. What did I write? 5.5-ish. We don't even need to be that accurate. So 3,605.55-ish. If we divide that, you get about 1.803. So I'm not even going to leave it as a fraction, I'm going to leave it as a decimal. So now I can do this piece here. So secant squared theta is 1.803 squared times theta prime equals 1 over 2,000 times y prime, and y prime we know is 1,200. All right, so right off the bat, those two zeros are going to kill off those two zeros. So this becomes 12 over 20. 12 over 20 simplifies to, let's see, I can divide both of those by 4. That becomes a 3. And that becomes a 5. So that's just going to simplify to 3/5. Cool. So theta prime is going to be 3. What we would do to solve here, let me back up one step. Here I'm going to divide both sides by whatever that number is. So it's going to be down here, 1.803 squared. So put that all into the calculator, and 3 divided by 5 times 1.803 squared comes out to be about 0.185 radians per second. Okay. The problem is really the same as the last one. The only difference is the numbers aren't as nice, but the process was still the same, so it's good to see it twice. All right. And then last example, a 26-foot ladder is leaning against a building. The base of the ladder is sliding away from the building at a rate of 3 feet per second. Consider the moment when the base of the ladder is 10 feet away from the building. At what rate is the angle between the ladder and the ground changing? So let's start with the diagram here. We got our house, we got the ground, we got a ladder up against it. We have the angle that the ladder makes. The angle between the ladder and the ground is right here. It's a 26-foot ladder. The base is sliding away. So I'm going to call it, you can call this A and B. I just call it X for horizontal and Y for vertical. The base of the ladder is sliding. Consider the moment when the base of the ladder is 10 feet away. So at some point, X equals 10. But that's not constant because it's sliding away. The base of the ladder is sliding away from the building at a rate of 3 feet per second. So X prime is 3. It's sliding away, so X is getting bigger, so it's positive. Constant. Consider the moment when the ladder is 10 feet away from the building. At what rate is the angle between the ladder and the ground changing? So we're trying to find out what is the rate of change of that angle. And as this ladder is sliding away, that angle should be getting smaller. So I'm expecting a negative number here. So in this case, what's the constant here? Well, as the ladder slides this way, so the ladder is sliding away from the building, why is the height that the ladder reaches is getting smaller and smaller and smaller, but the length of the ladder doesn't change. The length of the ladder is always 26. So in this case, this is the constant. So we got to pick a trig function that relates my constant length to my changing length that I know. So the changing length that I know is x. That's the adjacent leg. The constant 26 is the ladder. That's the hypotenuse. So the function that relates adjacent to hypotenuse is cosine or secant, but I want that hypotenuse to be on the bottom, so I'm going to use cosine. So cosine theta is the ratio of the adjacent leg to the hypotenuse. And the adjacent leg we're going to call x. And the hypotenuse, I'm going to call it 26 because it's a constant. I can use that. So if I take derivative of both sides, derivative of cosine is negative sine theta equals 1 over 26 times x prime. So sine theta is the opposite over hypotenuse. hypotenuse is 26. I just don't know what the opposite leg is. So we got Pythagorean theorem this thing. So we're going to do 10 squared plus y squared equals 26 squared. So y is going to be whatever 26 squared minus 100. Excuse me, 10 squared is. What do I get when I do that? You get 24. Nice. So we have a 5 times 2, 12 times 2, 13 times 2. So this is really a 5, 12, 13 Pythagorean triple. 5 times 2 is 10, 13 times 2 is 26, 12 times 2 is 24. So this is those numbers form a Pythagorean triple for anyone that cares. Anyways, so this is 24. That simplifies to 12 thirteenths. Okay, so now I'm going to plug that in. So we have negative sine theta, and sine theta is 12 over 13. Oh, I forgot the times theta prime. So times theta prime equals 1 over 26 times x prime, which we know is 3. So we're getting there. So what I would do here is I multiply both sides by negative 13 over 12. So the 13s cancel, the 12s cancel, the double negatives cancel. So on this side, what do we got here? 3 over 12 is just 4. So let's see what else we got. 13 over 26, so that's nice. Is just 2. So 2 times 4 is 8. And on the top I have 1, and it's like a negative, so it's just negative 1/8. Perfect. So if you're not sure what I did, 126 times 3 times negative 13 over 12. Try figuring that out, and you should get 1/8. Again, 3 over 12 just became 4. 13 over 26 became 2 on the bottom. So on the bottom, I have a 2 times 4, which is going to give me the 8. And then the 1 and the negative is going to give me the negative 1. So that's our answer. Anyways, that's it. We're just going to get a lot of practice next class. And we'll get better at it. All right. That's all. Oh yeah. Like, share, subscribe, ring the bell for notifications. If you have any questions, I'd love to hear it in the comment section.